Thank you very much, Anna. Now this very energetic 7 minutes I have, it's very difficult to send you a message. But what we have seen earlier that we are facing eutrophication and climate change, but we are also facing marine acidification. And this has been addressed by this Baltic-C activity. And you know that there are lots of measurements on pH in the Baltic Sea, and in general it's very around 8. So the Baltic Sea is not acid below 7 in the surface water, but it's very controlled by the biologic activity. And what we have done is been using very new type of measurements by this Finn partner, taking PCO2 measurements from the Baltic Sea by this ferry going from Helsinki to Travemünde. And this is a new data source that gives lots of information about what is going around in the Baltic Sea, about how much biological production the Baltic Sea is doing, and how that is working. So that has been a very important source for the modeling we are doing. So what we are doing with the modeling, we are using global climate models and regional climate model, and then we are driving 3 types of models. We use a terrestrial carbon model that calculates what will be the change in the trees or the organic carbon content on land, and how that will go into the rivers and how that will go into the Baltic Sea. And you know that the coastal seas, they link really the continent and the ocean by fluxes of freshwater and matter. And to be able to address the threats to the Baltic Sea, you really must take into account the land, what is happening with the land. This is one example of pH in the future, and it's a surface water without assuming anything about climate change, but just assuming that we will have increasing CO2 in the atmosphere. And what you can see is during the 1950, the amplitude was starting to increase due to eutrophication. So we see here the eutrophication start, but the eutrophication is not winning. It's the CO2 in the atmosphere that is winning. But if we are putting into the land system a combination of increased eutrophication to the Baltic and increased CO2 to the atmosphere, we will see that there will be a large amplification of the seasonal cycle of pH. During summer we will have higher pH, but during winter we will have lower pH, and that will be the threat for the Baltic Sea, the winter values. And as you know, it's the winter water that is entering into the deeper part of the Baltic Sea. So it will be as a systematic introduction of more acid water during winter to the system. So what the main message is coming out from this Baltic Sea? Pardon? The main message on the Baltic Sea is that acidification is a problem related to climate change, and that we will also see that in the Baltic Sea in the future. It will be a competition between eutrophication and acidification for the surface water during summertime, but during wintertime the surface water will become more acid, and that will also influence the deeper parts. So, and how acid it will become, it's a management option. So what we are now speaking about is management option of the Baltic Sea. And the management option is not just to reduce the nutrient inflow, it's also to reduce the CO2 into the atmosphere. So I'm sorry we have taken that. So there is really management challenges for the future. We are waiting. We think that with a warmer climate we will have more problem with anoxic and hypoxia, but we will also have problems with acidity. So to be able to address this, we must address both eutrophication, climate change, and acidification as 3 threats, and to have smart management of that. So I would really say that humanity here have really challenged for the future.